Welcome! Today, we're turning our gaze to the southern skies, but not just to look at a random pattern of stars. No, we're looking at a concept, an idea drawn onto the celestial sphere, the constellation Microscopium. You see, this isn't a place of ancient gods or mythical beasts. Think of it more as a celestial laboratory, a monument to human intellect, and our unending quest to see what lies just beyond our sight.
And this quote, this really gets to the heart of it all. The parallel here is completely intentional. Microscopium, both the instrument on a lab bench and the star pattern in the sky, demands a very specific mindset. It's not something that gives up its secrets with a quick look. It rewards patience, focus, and a methodical investigation. That's the theme we're really going to unpack today.
So, to really get a handle on Microscopium, we first need to understand the man who created it and the era he lived in. We have to travel back to the 18th century, into the mind of a French astronomer named Nicolas-Louis de Lacaille. Now, this was a man who looked at the night sky and didn't see a canvas for myths, but a map that needed to be filled in with the tools of human progress. Let's just walk through this timeline for a moment. Between 1751 and 1752, Lacaille set up shop at the Cape of Good Hope and undertook this absolutely massive project to chart the southern sky. And what's so different here is that unlike, say, Orion or Ursa Major, which were born from thousands of years of mythology, Microscopium was a deliberate modern creation. It was officially put on the map in 1756, a true product of the Age of Enlightenment. It was basically a philosophical statement, placing a symbol of scientific reason right up there with the stars. Now, here's a really crucial point. It's so tempting to think, oh, the microscope, that must be for Antony van Leeuwenhoek, the father of microbiology. But Lacaille's vision was much, much bigger than that. He wasn't honoring just one man. He was immortalizing the tool itself. The microscope, this thing of glass and brass. It represented a brand new power for humanity, the power to see the invisible, to take the infinitely small and drag it into the world of human knowledge. Okay, so before we can actually place a specimen under our celestial microscope, we need to understand the instrument itself, right? We have to do a little calibration. So let's build our observational framework by looking at the constellation's basic properties. Think of this as getting our focus just right before we begin the real analysis. And what's fascinating when you look at this data is just how modest it is. Microscopium is small, ranked 66th out of 88 constellations in size. Its brightest star, Gamma Microscopii, is a faint magnitude 4.67. That's barely visible to the naked eye and only if you're in a really dark spot. It just sits there in this seemingly empty patch of sky south of Capricorn. But that faintness is exactly the point. Its importance isn't in how bright it is, but in the incredible scientific treasures it's hiding. So the next logical question is, can you actually see this thing? Well, this slide shows you its global reach. If you're anywhere south of about 45 degrees north latitude, we're talking the southern US, the Mediterranean, you can see the whole constellation. Any further north than that, it just kind of scrapes along the horizon. And if you're above 60 degrees north, forget it. It's always below your horizon. The best time to try and spot it when it's at its highest point is during August and September. All right, our instrument is calibrated. We know where and when to look. Now it's time to place our first and maybe our most significant specimen onto the observational stage. We're zooming in, way in, on a single point of light within the constellation's boundaries, the star system known as AU Microscopii. Now, to really appreciate what we're about to see, we need to define a key term, a debris disk. I want you to picture a gigantic, messy ring of dust, ice, and rock just swirling around a young star. This isn't a nice, stable, mature solar system like ours. Oh no, this is a planetary construction zone. It's a chaotic, dynamic, incredible nursery where entire worlds are being born. And the AU Mix system is a perfect case study. Right at the center, you have a young, feisty red dwarf star, which is astronomically speaking right next door at just 32 light years away. Around it is one of the most studied debris disks we've ever found. And then, the clincher. In 2020, we actually confirmed the existence of a planet, AU Mic-B, a gas giant that's still forming inside that swirling cloud. Studying this system is essentially like having a time machine. We're getting to watch the very same processes that shaped our own solar system billions of years ago. Okay, let's adjust the focus on our celestial microscope a bit, because beyond that amazing planetary nursery, this constellation is hiding other unique specimens. We're talking about stars that behave in really extreme ways, pushing the boundaries of what our models can explain. let's take the star HD 197890, which has the great nickname Speedy Mike. Now, there's a common error you'll see in some places that says its rotation period is just 7 minutes. That's actually incorrect. It's probably a mix-up with the timing of its stellar flares. As you can see here, the real period is about 9 hours. Now, while that's not 7 minutes, it's still incredibly fast for a young star. Studying the huge star spots on its surface gives us priceless data on the kind of magnetic chaos our own sun went through in its youth. It's a perfect example of why rigorous verification is so critical in science. We're now going to make a pretty significant change in magnification. We're shifting our focus from individual stars just a few light years away to scales that are almost impossible to comprehend. We're going to peer right through the foreground stars and look deep into the intergalactic void. Our new target is NGC 6925, and this isn't a star. This is a city of billions of stars, a spiral galaxy very much like our own Milky Way that we just happen to see almost perfectly edge-on. Through a telescope, it looks like this impossibly thin, elegant sliver of light against the black. The year is 2011. Remember that year, because in 2011, inside that distant sliver of light, astronomers witnessed an event that had profound importance for cosmology. A star inside NGC 6925 blew itself apart. To be specific, it was a Type A supernova. Now, what's so special about these explosions is that they have a known, predictable peak brightness. That means they work like a standard candle. If you know how bright something is supposed to be, and you measure how dim it appears, you can calculate its distance with incredible precision. This one event, SN 2011A, in an obscure galaxy in a faint constellation, gave us a crucial data point that helped us refine our measurement of the Hubble constant, the actual rate at which our entire universe is expanding. And finally, let's pull back from the purely physical and look at the symbolic. Microscopium doesn't have any ancient myths, that's true, but you could say it has its own scientific mythology, a story, a meaning that's embedded in the very way it was placed in the sky. You see, Lacaille's placement was a deliberate choice. He put Microscopium, this tool of logic and reason, right next to the ancient, chaotic, mythological figures of Sagittarius the centaur and Capricornus the sea goat. It's like a manifesto written in the stars, saying human science now stands ready to analyze and bring order to the wild mythic universe. And it gets even better. The lens of the microscope points towards another one of his constellations, Indus, the Indian, which represents humanity. The metaphor is just so powerful, science turns its gaze not only outward to the cosmos, but inward to understand ourselves. So after this entire examination, from its Enlightenment roots to its cosmological importance, we have to ask the big question: what is the ultimate message that's encoded in this faint little pattern of stars? I think the conclusion is inescapable. The real lesson of Microscopium is a lesson about the nature of science itself. It tells us that the greatest truths, the most profound discoveries, are rarely found in the brightest, loudest, most obvious places. Instead, the real revelations, the birth of new worlds, the very expansion of our universe, are often waiting for us in the dark, quiet, overlooked corners of the sky, accessible only to those with the patience, the tools, and the sheer will to look closer.